Hello friends, welcome. Have you ever had a moment where you just wished for more? Not more stuff, not more money, but more you. A moment where you're looking for your keys and you think, I wish I just knew where they were. Or you're trying to learn a new skill, a new language, and your brain just feels slow, full. You wish you could just download it right. Or maybe it's something deeper. Maybe you've seen someone you love struggle. A grandmother whose hands tremble so much she can't hold a teacup. A friend who lost a limb in an accident. A child who can't hear the world around them. And in those moments, that feeling of human limitation, it's heavy, it's frustrating. We are these brilliant, creative, feeling souls, and yet we are trapped inside these wonderfully flawed biological machines that get sick, get tired, and forget where we put the keys. For most of human history, that was just the deal. We used our minds to build external tools to compensate. We invented a hammer to hit harder, a wheel to move faster, a computer to think bigger. Look at this thing in your pocket, your smartphone. It's an external brain, isn't it? It holds your memories, it handles your navigation, it answers your questions. It's an augmentation of you. But it's outside. It's separate. You have to tap on a piece of glass to use it. But what if the tool wasn't in your hand? What if the tool was part of your hand? What if the computer wasn't in your pocket but was simply a part of your thoughts? What if we could bridge that final, fleshy gap between the human and the technology? Not to lose our humanity, but to enhance it, to restore it, to take that feeling of limitation and edit it. This isn't science fiction. This isn't a movie plot. This is a real, emerging field of engineering. And the person who builds that bridge, the person who designs that connection, they have a few names. Some call them a Human Augmentation Engineer. Others, a bit more poetically, call them a Cyborg Interface Designer. And that is what we are going to talk about today. Who is this person? What do they actually do? What world are they building? Because, make no mistake, they are building the world our children will live in. They are the architects of the next version of humanity. This is a deep topic. It's complicated, it's a little scary, and it's absolutely fascinating. What we're talking about today isn't just a new job title. We're talking about the very definition of what it means to be human. And by the end of this conversation, you will understand not just what this job is, but the profound ethical, philosophical, and human questions these engineers have to ask themselves every single day. So get comfortable. This is a journey worth taking. I promise you, by the end of this, you will see the world and your own body in a completely different light. Let's dive in. So let's start with the basics. Who is this Human Augmentation Engineer? If you say cyborg, most people picture the Terminator. A metal skeleton, a red eye, a machine pretending to be human. Or maybe they picture something from a cyberpunk movie, all neon wires and robotic arms. And that's all about fear. It's about the machine replacing the human. But the reality of human augmentation is quieter, it's more intimate, and it's already here. Do you wear glasses? That's a human augmentation. You've used a piece of sophisticated ground glass technology to correct a biological limitation. You have augmented your vision. Do you know someone with a pacemaker? That is a sophisticated computer, a piece of technology, fused with their heart, keeping them alive. It is a perfect, life-saving fusion of human and machine. What about a cochlear implant? This is one of my favorite examples. A cochlear implant doesn't just make sounds louder like a hearing aid. It bypasses the damaged part of the ear and translates sound, the world, into a series of electrical signals, and it feeds those signals directly to the auditory nerve. The brain then learns to interpret these new digital signals as sound. Think about that. The person who designed that engineer, they had to be more than just an electrical engineer. They had to be a neuroscientist. They had to understand how the brain makes sense of the world. They had to be a translator, teaching two completely different languages, the language of digital code and the language of human neurology, to speak to each other. And when you see those videos, the ones where a child's implant is turned on for the first time, and they hear their mother's voice and their eyes go wide, that is the work of a human augmentation engineer. It's not about replacing humanity. It's about restoring it. It's about using technology to give someone back a piece of the human experience they had lost or never had to begin with. So this is the first and perhaps most important domain of this new engineer: restoration. The engineer in this space is building sophisticated prosthetics, not just the plastic and metal ones, but bionic limbs, arms that can be controlled by thought. This is happening right now. At places like the Applied Physics Lab at Johns Hopkins, they've developed arms that connect to the wearer's nerves. When the person thinks close hand, their brain sends the same signals it always did. The engineer's job was to build an interface that could read those faint, messy, biological signals from the nerve endings, use artificial intelligence to decode the intention in that signal, and then translate that intention into a mechanical action. And it goes the other way too. The best interfaces aren't just one-way streets. The new generation of these prosthetics have sensors in the fingertips, and when the user touches something, the sensors send a signal back up into the nerves. The engineer has to figure out what's the electrical signal for soft, what's the signal for hot, what's the signal for sharp. They are designing feeling. They are designing a two-way conversation between flesh and steel. This is not a job for someone who just likes code. This is a job for someone who is part biologist, part psychologist, part artist. The user interface they are designing isn't on a screen. The user experience is the feeling of holding your child's hand. This is the Cyborg Interface Designer part of the title. They are designing the scene. How do you attach something that is rigid, digital, and synthetic to something that is soft, wet, organic, and constantly changing? Think about your own body. It's a battlefield. Your immune system is designed to find anything that isn't you and destroy it. So, a huge part of this job is material science. What can you build that the body won't reject? How do you create electronics that are flexible, that can live in a warm, salty environment, which is what your body is, for decades without corroding or poisoning you? The engineer has to think like a biologist, designing tech that can trick the body into accepting it, tech that can heal with the body. So this restoration phase is where the work is most obvious, and it's the most undeniably good. These engineers are giving people the ability to walk again, to hear again, to feel again. They are solving profound human problems. But, as with any technology, it doesn't just stop at restoration. The same technology that allows a paralyzed man to control a robotic arm could allow a healthy person to control a third robotic arm. The same interface that allows a cochlear implant to send sound to the brain could, in theory, be used to send other things. And this is where we move from the present, from restoration, into the near future. This is where the engineer's role shifts from therapist to architect. This is the realm of enhancement. If we can build an interface to restore, we can also build an interface to add, to exceed the human baseline. And this is where the job title, Human Augmentation Engineer, starts to feel a little bigger, a little more science fiction. Let's talk about what this means. Enhancement can be physical. Think of an exoskeleton. Right now, there are engineers designing wearable robotic suits, not for people who are paralyzed, but for factory workers or soldiers. A suit that takes the load off your back, that lets you lift 200 pounds as if it were 20. The engineer here is designing an interface with the whole body. They have to study a person's gait, their center of gravity. They have to build a machine that anticipates your movement, that moves with you, not against you. A badly designed interface doesn't just feel clunky, it can break your hip. The user experience here is the feeling of being powerful, of being seamless. Or let's take it a step further. Let's talk about sensory enhancement. Our biology gives us a very, very narrow window on reality. We only see a tiny sliver of the electromagnetic spectrum. We call it visible light. We can't see infrared. We can't see ultraviolet. We can't sense magnetic fields like a bird. But we can build sensors that can. So the Human Augmentation Engineer asks the question, What if I took a sensor that can see in infrared and hooked it up to your brain? What would that even feel like? There's a famous biohacker, a man named Neil Harbison. He was born completely colorblind. He's an artist, so this was a profound limitation for him. He worked with an engineer to have an antenna, yes, an antenna, permanently implanted in the back of his skull. This antenna has a sensor on the end. It detects the frequency of the color in front of him, and it translates that frequency into a sound, a specific note, that is transmitted to his inner ear through bone conduction. He doesn't see color, he hears it. He says that the grocery store is a symphony. He says he can hear people's faces. His brain, being the magnificent plastic thing it is, learned this new data stream. It adapted. He now dreams in color sounds. He is, by his own definition and the legal definition of some governments, a cyborg. The person who helped him build that was a human augmentation engineer. Their job was to ask, how can we take a data stream the human body was not designed for and find a port, a place to plug it in? In this case, the port was the auditory system. Now imagine an engineer scaling this. What if a surgeon could feel the magnetic field of their tools inside a patient's body for microscale surgery? What if a firefighter could see in infrared, not on a clunky visor but just as a new sense, letting them find people in the smoke? This is what the engineer is designing. They are designing new senses. They are designing new ways to experience reality. This is complex, right? We're talking about fundamentally rewiring the human experience. We're moving from fixing what's broken to designing what's next. And if you find this kind of deep dive into the future, the human, the technology, if you find this fascinating, do me a favor. Just pause for a second and hit that like button. It's a tiny little click for you, but it sends a huge signal back to me that this is the kind of conversation you want to have. It tells me you want more of this, more exploring the absolute edges of what's possible. And if you haven't yet, seriously, consider subscribing. We're not just a channel. We're trying to build a community of curious minds here, people who aren't afraid to ask the big questions. So join us. We're saving a seat for you at the table. Okay, so we've talked about restoration, fixing the body. We've talked about enhancement, adding new physical or sensory abilities. Now we have to talk about the final frontier, the one that makes people the most excited and the most terrified. We're not talking about your muscles. We're not talking about your eyes. We're talking about your brain. This is the domain of cognitive augmentation, and the engineer who works on this. This is the Cyborg Interface Designer in the purest sense. They are designing the interface between a human thought and a computer. This is the world of BCIs, brain-computer interfaces. You've probably heard of companies like Neuralink. The idea is to go beyond the ports we already have, like our eyes and ears, and create a new, high-bandwidth port directly into the brain. So, what does the engineer here do? First, they are a neuroscientist, or at least they work so closely with them you can't tell the difference. You cannot design an interface for a machine if you don't understand that machine. And the brain is the most complex, most bizarre, most powerful, and least understood object in the known universe. It's not a computer. It's not a hard drive. A computer stores a 1 in a specific place. Your brain doesn't store the memory of your grandmother in one neuron. That memory is a pattern of connections, an echo of electricity distributed across millions of cells. It's like a ghost. So the engineer's first problem is, how do you read the ghost's mind? You can do it from the outside. This is called non-invasive, using a cap with electrodes that read the faint electrical noise from your scalp. But that's like trying to understand a conversation in a stadium by listening from outside the stadium. You can tell if the crowd is cheering or booing, but you can't hear the individual words. The real cutting-edge work is invasive. It's about putting the microphone inside the stadium. This involves developing threads or arrays, tiny microscopic electrodes that can be safely inserted into the brain tissue. This is a massive engineering challenge. Again, the brain is soft, it's wet, it's jello, the electronics are hard, they are rigid. How do you merge them? The engineer has to design materials that are flexible enough to move with the brain, but conductive enough to pick up the impossibly tiny signals from individual neurons. Once the hardware is in, the real magic and the real engineering begins. This is the software side. Your brain is firing off billions of signals right now. It's regulating your breathing, it's keeping you balanced in your chair, it's processing my voice, it's thinking about what you're having for dinner, it's remembering a song you heard yesterday. It is chaos, a beautiful, functional chaos. The engineer's job is to find the signal in that noise. Their job is to build the decoder. This is where artificial intelligence and machine learning are absolutely essential. The engineer builds a software system, an AI, and essentially says to it, "Okay, I'm going to ask this person to think about moving their hand to the right. Watch the 10,000 neurons I'm listening to. Watch them. Now he's doing it. See that pattern? That right there. That's the pattern for move right. Learn that pattern." They do this thousands and thousands and thousands of times. The AI gets better and better at recognizing the intention, the shadow of the thought. And then they connect that pattern to an output. They connect it to a computer cursor, and the person, for the first time, thinks move right, and the cursor on the screen moves right. Can you imagine that? Can you imagine the feeling? This is what engineers are doing today for people with locked-in syndrome, people who are fully conscious but can't move a single muscle. They are designing an interface that gives them a way to communicate, a way to type, just by thinking. That engineer is designing an interface for thought itself. But this brings us to the next logical step. Right now, we're talking about reading and outputting. The connection is one way, brain-computer. What about the other way? What about computer-brain? What about writing information to the brain? This is a whole different level. We know it's possible. That cochlear implant, it's writing to the brain, it's sending signals, but it's sending them to a peripheral nerve, the auditory nerve. What about writing to the cortex, the part that thinks? What would that even mean? Could you upload a skill? Could an engineer design a package of signals that, when fed to your motor cortex, gives you the muscle memory for a piano concerto? Could you have a thought, and instead of just thinking it, you could save it like a file and then share it? Could I have a feeling, a complex emotion? And could a Cyborg Interface Designer build a system that records the neural state of that feeling, and then I could send it to you? So you don't just know how I feel, you literally feel it yourself. This is where the engineer's role becomes, well, almost godlike. And this is where we have to stop and talk about the other half of their job, the part that no one puts on the business card. The Human Augmentation Engineer must be an ethicist. You cannot build a bridge to the human brain without being a philosopher. You just can't. If you do, you are the most dangerous person on the planet. This is the fourth and arguably most critical block of their work, designing for humanity. Every single choice this engineer makes has a moral, an ethical, a human consequence. It's not like designing a to-do list app. If a to-do list app has a bug, you forget to buy milk. If a brain-computer interface has a bug, what does that even mean? Let's walk through the minefield they live in. First, the gap, the digital divide. We talk about the divide between people who have smartphones and people who don't. Now, imagine the augmentation divide. What happens when this technology is available, but it costs $1 million? What happens when the wealthy can buy a cognitive enhancement? When they can buy a neural lace that connects them to AI, that makes them think faster, remember more, learn instantly? And the rest of humanity can't. What does a job interview look like in 2050? Do you have a standard biological brain, or do you have the Cortex Plus upgrade? What does that do to society? We're no longer just talking about class stratification. We are talking about biological stratification. a literal splitting of the human species into the aug-haves and the aug-have-nots. The engineer, the one building this, they have to ask that question. Is what I'm building only for the rich? Can I design this in a way that is scalable, that is accessible? Or am I, by the very act of my creation, building a world of gods and mortals? That's a heavy, heavy burden. Second, security and privacy. This is the one that keeps me up at night. If your brain is connected to a network, can it be hacked? We are terrible at digital security. Our passwords get leaked, our emails get read, our webcams get taken over. Now, imagine the stakes are your brain. What is ransomware? For your memories. Pay us 10 Bitcoin or we will delete the memory of your wedding day. What is a virus? That can change your political opinions or your preference for a brand of soda. What is surveillance? When a corporation or a government doesn't just know what you search for, they know what you think before you even type it, when they can read your subconscious. The Human Augmentation Engineer is the only person who can build in the safeguards, the only one. They have to be the world's greatest cybersecurity expert. They have to invent new kinds of encryption. They have to design systems where perhaps the data is decoded on the chip in your head and never leaves. They have to build firewalls for your soul. They have to champion privacy by design at a level we can't even comprehend. The user must have ultimate, inalienable control. But how do you design that? How do you build an off switch when the on switches you? Third, and this is the most philosophical one, identity. Who are you? Right now, your sense of self is, well, it's you. It's your thoughts, your feelings, your memories, your choices. Now, let's add an AI. Let's say you have a neural lace, and you're trying to solve a hard problem, and the AI coprocessor in your head whispers a solution to you, a brilliant solution, one you would never have thought of. Who thought of it? Was it you, or was it the AI? And if you act on that thought, whose action is it? If your moods, your emotions, can be regulated by an app, if you're feeling sad and you can just dial up the serotonin setting, are you still you? Or are you just a well-managed piece of hardware? If you have a thought, a bad thought, a thought I shouldn't be having, and the interface deletes it before it even reaches your consciousness because it violates a terms of service agreement, are you still free? Or does the human end and the machine begin? The Human Augmentation Engineer, the Cyborg Interface Designer, is the one who draws that line. They have to. They are designing the user interface of your consciousness. What a job, what a responsibility. They're not just building a thing, they are designing the experience of being. They have to be more than engineers, they have to be humanists, they have to be guardians. They have to, I think, be kind. They have to have a deep, profound empathy for the human condition they are seeking to change. They have to remember the person, the grandmother who wants to hold a teacup, the child who wants to hear their mother. The human in human augmentation has to be the most important word. So, this is the world of this new engineer. It's a world that's part medicine, part robotics, part artificial intelligence, part material science, and a very, very large part, philosophy. It's the person who understands that a BCI isn't just a circuit, it's a conversation with the soul. It's the person who understands that the interface isn't a screen, it's a synapse. It's the person who has to balance the dream of transcendence with the reality of human frailty. This is, without a doubt, one of the most important jobs of the 21st century. These are the people who are holding the blueprint for our future. So, what do we do with all this? It's a lot. It's big, it's scary, it's beautiful, it's full of promise, and it's full of peril. And it's not a question of if this is going to happen. It is happening. The breakthroughs in restoration are happening now. The experiments in enhancement are underway. The first steps into cognitive augmentation are being taken. The genie is not going back in the bottle. So when we look at this role, this human augmentation engineer, we're not just looking at a career path for some brilliant kid in a lab. We're looking at a new kind of human endeavor. There are really two big, final thoughts I want to leave with you. First is that this field, this whole idea, it forces us to finally really understand ourselves. You cannot build a good interface for the brain if you don't deeply understand the brain. For decades, we've been trying to understand consciousness by, well, just thinking about it. But now, to build a BCI, you have to map it. You have to decode it. You have to understand the mechanics of a thought, the physics of a memory. In a strange, beautiful, ironic way, this quest to merge with machines might be the very thing that forces us to finally, truly, understand what it means to be human on a biological level. The most cyber of all sciences might end up being the most humanistic. It's not about running away from our biology. It's about a new, profound incentive to run towards it, to understand it in all its glorious, messy complexity. The best engineers in this field will be the ones who are also the best biologists, the best psychologists. The second, and this is the most important thing I can say today, this is not a future that just happens to us. It's a future that we build. And when I say we, I don't just mean these engineers, I mean all of us. These engineers, they are going to build the options. They will create the tools, but we as a society, we have to create the rules. We have to be the ones who have this conversation. We have to be the ones who decide. What are the ethics? What are the boundaries? We have to decide what hacked memories means in a court of law. We have to decide how to prevent the augmentation gap. We have to decide what human even means and what parts of it are non-negotiable. We can't just be passive consumers of this future. We can't just sit back and see what happens. We have to be active participants. We have to be informed. We have to be, well, we have to be the human side of the human-machine interface. The person who designed the cochlear implant, they gave a child their mother's voice. The person who designed the bionic arm, they gave a soldier the ability to hold a glass of water. The human augmentation engineer is the architect of the most intimate, most personal technology we will ever create. They are building a bridge that leads from what we are to what we could be. And our job is to make sure that we like the world on the other side of that bridge. Thank you for thinking this through with me. This is the work, asking these questions, being curious and being human. If this conversation meant something to you, if it sparked something in your mind, please share it. Talk about it with someone. The more people we have thinking about this, the better. And of course, if you haven't, please subscribe. We have so much more to talk about. Until next time, stay curious, stay human.